So as I've given you a bit of a background on rebar versus anchor, and also we've looked at the different design methods you can use to utilize based on different applications. Now I'll let my experienced colleague Randy take over, who will take you through the latest module in process engineering for designing post-install reinforcement connections. Over to you, Randy.
Awesome. Thanks, Demish. So hello, everyone. My name is Randy, as Demish has mentioned. I'm the engineer based in WA. And for today's session, I'll be going through the new post-install rebar module in PROFIS Engineering. So as you can see from the screen here, this is the main homepage for PROFIS Engineering. Before we start the design, I would highly recommend that we first go into the settings by clicking this code on the left-hand tab here. And what it does is it will bring up the settings for the PROFIS Engineering software. We want to make sure that the region is set to Australia. By doing so, it will ensure that your design method is applicable to the Australian standards. So from there, we can click Save. And from here, what we can do is select the post-install rebar module. As you can see, this is new and was not available before. So once we have clicked that particular module, it will then bring up the homepage for the design interface. As you can see here on the left-hand tabs, we do have a few options here. So the first option that I would like to go through is the Applications tab, where we can actually define the types of connection and also the types of application. So for this, to start off with, let's begin with lap splicing and slab-to-slab connection, which is pretty standard. When we actually click this particular application, we can see that it is designed as per the Australian standards, AS5216 plus AS3600, and the development length over here is designed to yield, which is the requirement for AS3600. Note that you can see here there is loads that can be entered as well. So in this instance, by default, it's set as 25 kilonewton meter. We can remove this as an example, or then remove the post-installed rebar, because then we wouldn't need any post-installed rebar if there's no forces. So let's reapply back that 25 kilonewton meter and reapply the post-installed rebar. So moving on from there, the next step that I would like to cover is the concrete member tab. So by clicking this tab, we can see that there's some options here to change the parameters of the base material. First one being the existing concrete material, which is default set to be at 32 MPa. And on the instance where you like to enter a custom compressive strength, simply select this button here, and then it will bring up the option for you to enter the cylindrical compressive strength and also the elasticity modulus. You can see here the same settings also apply for the new concrete member. The next option that we have here is the temperature options, where we can adjust the short-term and long-term temperature. And the reason why there's these settings here is we know that chemical anchor does get affected by the temperature of the base material, and this will adjust the performance of the anchor accordingly by entering the right temperature of the base material. Moving on from that, we also have the installation conditions, where we have the option to select the drilling type, hammer drilling, diamond coring, hole type, and also whether drilling aid is being used. And the reason why this is available here is that when, let's say, diamond coring is selected, the software automatically filters out all the products that is not approved for diamond coring. So it is providing you, the designers, a bit of layer of safety to make sure that the right product is selected for this design. Moving on from there, we have the existing reinforcement tab, which then we can actually input the reinforcement yield strength and then also the reinforcement layers. As an example here, the top layer setting is selected. We can define the number of layers, whether it's 0, 1, or 2 layers. We also have the option to select the shape, whether it's straight or hook / stirrup. We can define the front cover, the diameter of the rebar. We can also define the bar arrangement through the spacing, which then will just input the value here. Or we can also select by defining the number of bars across the section. So by selecting this, we can define the number of bars, either 7 or 8 or 5, and it will automatically spread it out evenly across the section. So moving on back, we also have the option to dictate how much top cover is there in the connection. So the next tab that we'll be looking at is the products tab, where over here we can actually select the different products that is available for this configuration. So in this instance, because right now only RE500 and HY200 is approved for this design method across Australia, these are the only 2 products that's available for selection. On top of that, all of our products is also ETA approved products. And in order to view the approval document, simply clicking this button here, it will open up the ETA approval document for that relevant one. On top of that, we also can define the reinforcement yield strength and rebar positioning. Right now, it's set as automatic. On the case where we would like to set it as user-defined, we can do so by selecting the user-defined option, and pretty much the same option is available as we are defining the existing reinforcement. So moving on back from that, we will be talking about the loads and design method tabs next. And for this particular tab, we can see that we can define the design working life, whether it's 50 years or 100 years. And we can also define the load definition, whether we will be applying the load on the section itself or per bar. So let's say if we were to select per bar, what it does is you will notice that the black arrow is now gone. Instead, we have all these little blue arrows on the rebars. And what it allows us to do is enter the load on each layer of the reinforcement bar rather than applying it to the actual section itself. So on top of that, we also have the option to consider additional tensile force due to shear. And this is, let's say, if you like to understand more about what this function actually does, simply click this option here, and it will provide the reference on which part of the standards it is actually taking this calculation from. Similarly, for the interface shear check here as well, this can be done by simply checking this button here. And on the right-hand side, what you'll notice here, the option for interface shear check is now also shown on the utilization. Right now, because there's no shear on the interface, and therefore it's at 0%. So moving on, we'll go back to the applications tab. And in this instance now, we'll be selecting end anchorage instead of lap splicing, which will be defined as per the new design method, which has been just covered by my colleague Damish. So selecting end anchorage provides us a list of new applications that can be selected here. Selecting water slab as an example, just for these demonstration purposes, it will bring up the connection water slab to wall. And by default, again, it has already defined 25 kilonewton meter moment, which was not available in the previous design method, which is the AS3600. Now with this new design method of AFEC technical node, this is allowable. And this basically opens up a whole new set of configurations that was not covered in AS3600 before. And what you'll notice here as well on the right-hand side, you can see that the technical node 8 is now available as a design method rather than just the AS5216 plus AS3600. So The options following this is pretty much the same. So I will not go into detail on what can be adjusted for this particular design application. What I will do instead is move on to the right-hand side here. What you will see is the design coverage is checking all the 3 failure modes according to the technical note 8 requirements. So instead of just designing to yield, it now checked the steel utilization as well. It checked the concrete breakout utilization as well. And of course, it does check the bond splitting as well. So as you can see in this instance, the concrete breakout is governing the governing failure mode for this design. On the top right-hand side here, we can click to generate report, and I'll go through what all this, how does this all this calculation come about. So clicking this generate report, there's a few settings that we can edit here, but by clicking save and generate, it will automatically create a design report based on this connection that we have just designed in the interface. So once that has been loaded up, I will open up the report here. Okay, so what we have here now on the screen is the design report of that particular design approach. As you can see, the first page here shows the input data, which is basically all the parameters that we have defined in the model itself. So the design method will be effect technical note 8. We will be including the effect of shear, if there's any additional tensile load that will be applied, whether we'll be verifying the interface shear check as well, the product that's being used, the type of insulation and during direction, and the base material properties. So moving on from that, we can also see how the configuration is being set in the design. This is shown on page 3 and 4. And the next point that we'll be covering is the cross-section analysis, which is really important to provide us the resulting rebar forces. So something to note here is that the cross-section analysis that is done by the software is according to curvilinear stress blocks rather than rectangular stress blocks. This then will allow us to produce a more accurate results than the standard rectangular stress blocks. So all the calculations are shown here on the redesign report, which then gives us the resulting rebar forces over here. So with this particular tension force, what will happen next is that the software will automatically calculate the required embedment depth to counteract those tension forces on the rebars. So it does check the steel failure, concrete cone failure, and bond splitting failure, and make sure that the utilization does not go beyond 100%. So let's say if you like to know in a bit more detail how the calculation is done for each of these failure mode, what we can do is move on to the next page where we can actually see all the equations and calculations that was used to calculate those results. So as an example here, this particular equation has a reference from reference 2 of the document and also equation 4.3. Now, let's say if we were to go back to the previous page to actually see what reference 2 is, we can see that reference 2 is referring to IOTA TR69 equation 4.3. So as you can see, every single equation in this particular document is actually referenced to the relevant standards. So let's say in the future, there are a few variables that you like to have a bit more understanding and how it's being calculated. And if there's any possibility to tweak those variables, feel free to go inside the standard itself to have a look on whether it's adjustable. Moving on from that, something worth noting as well here is there is installation data that is covered in the report. So information like this, such as the product, the item number, the roughness of the surface, rebar diameter, spacing, top cover, is all listed here, including the working time and curing time of the epoxy as well. So this design report is not only handy for engineers, but also for contractors. So that is pretty much the design report itself. As you can see, there's one last check here that to basically go through all the parameters to say whether the connection meets the required design criteria. So there's the design report. I will quickly move back to the PROFIS Engineering interface itself. So something that is really handy is that there is this floppy disk icon here as well, which we can click. So let's say if we need to export this particular design file to another account or to another device, as an example, simply clicking this button here, it will automatically export the .PROFIS engineering file, which is a .pe file, and you can actually transfer that through your thumb drive or through email. There's also one handy tool here, which is called the specification text. So by clicking this specification text, it will bring up all the product, the item number, the hole type, drilling type, basically all the exact configuration on how this has been designed. So let's say if you're happy with this design and would like to transfer it to either your specifications or to your typical drawings, simply generate the specification text, copy it to clipboard, and paste it in your drawings or specifications. And that is it really pretty much for the software side of things. I will now pass it back on to my colleague, Demish.
Thank you, Randy. That was fantastic. So definitely the right tools to cover the new technical note as well as existing design methodology. So that's everything covered. There's also, I'd like to mention that Hilti is available to assist you in the area of design, which includes on-site support and testing. We have a team of consulting engineers throughout the country that will be able to work with you on your projects and provide professional support and guidance, seminars. Furthermore, we have the supporting software. As you've seen, the demonstration here is quite advanced and cutting edge and most up to date. So we hope you found the webinar informative. Now we'll take questions that haven't been addressed during the webinar. And Hamduna, if you're there, could you take us through the first question?
Yeah, so Damish, the first question was, what is the difference in design methodology between AFAC versus rebar design manual according to AS 3600 and how both embedment depths are different?
Yeah, good question. So the AFAC, I'd like to mention that AFAC technical note actually has two volumes, volume 1 and volume 2. So volume 1 is actually for you to be able to design it to development of the bar. And it typically consists of either just lap splicing with existing casting bar, or it's basically you are embedded so deep into the concrete that you are in the compression zone, so you design it for compression. Volume 2 is actually something that's totally brand new, but based on tons of research that's been recently done. And there's an EAD to back up the testing and assessment for it. That technical note 8 volume 2 actually covers moment connections. So this is basically, you can call it an amalgamation of both the designing it as rebar as well as designing it as an anchor. So you will find it to have different values because it will now check for bond splitting, it will check for steel as well as it will check for concrete cone as well. Mariana, my colleague, will now also share the technical note itself into the session. So feel free to download it and feel free to reach out to your counterpart within Hilti and to discuss further. So I hope that answers it. Next question, please.
The next question is probably for Randy. Randy, there's a question about the fire and seismic load type options if they're available on PROFIS Engineering under the region Australia.
Yep, great question. Thanks, Hamdona. So with regards to the design for seismic and fire load type, at the moment in Australia, there is no standards that actually can design as per those load requirements. That being said, however, PROFIS does have coverage in our European counterpart, and that is by selecting the relevant region itself. So when you select one of the European countries and ensure that the design method, instead of having AS5216 plus AS3600 or the AFAC nodes, you can simply change it to the Euro codes section. So 1992, part 1 or part 4.
Thanks, Randy. We also have a question probably to you as well, Randy. Is there a specification to define the surface roughening of the old concrete? Is there an aggregate interlock required on the software itself?
Yeah, so great question. With regards to the roughness of the surface, there is one option on the surface treatment tab where there was a drop down to either select the roughen or roughness. And by clicking that, it also allows us to define the coefficient that's being used for the calculation. So if you would like to have a better understanding of that, I would recommend to click on the info button, which is just the point at the tab. Maybe, Hamduna, will it be easier if my screen was enlarged? Yep. So this particular tab here, so let's say if a surface treatment would like to be adjusted, simply clicking this roughness and change it from roughened to mechanical concrete shear key as an example, and that will change the whole calculation itself. If you like to have a better understanding which coefficient it has been used, simply click the I button and it will open up this particular tab, which shows either 0.7 or 0.9, which is used as the mu for the calculation. Hope I answered that question.
Thank you, Randy. That was a great answer. So we've got a question about sharing the presentation after we're done. So yeah, we'll share the presentation with all attendees once we're done with today's webinar. We have another question. Can it be used to design PC wall to PC wall joint connection with vertical dowel bars and PC wall dowel bars into footing beam? The PC wall thickness is varies from 150, 175, and 200 mil thick. I think this is a pretty customized question where we have to go through a design. I guess here, as long as it falls in either the latch splice or an anchorage design, and it kind of falls within the design parameters of both design methods we have here, there should be no reason why we can't design for that specific instance using the software that we have here. Chang, I hope that answers your question. If you need clarification, maybe you can type exactly what you mean by your question. And then we have another question here. So it was mentioned that deep embedment depths should use a rebar design method and that the anchor designs with base plates or shear should use the anchor method. Is there a scenario which meets both criteria, and would you recommend using an anchor design or rebar design method? David, if you want to answer that one.
Yep, I'm just going to have a quick read. That one's done. So the question is there a scenario which meets both criteria? Would you recommend using the anchor design or rebar design methodology? So typically, like with anchor design, if it meets with the anchor design, that's where you can sort of call it safe. Some may call it conservative, whichever you feel comfortable with. The anchor design, because it's based on more the brittle nature of the concrete, hence you may end up having to account for more failure modes. So if there's a scenario where in your case for the bar, where it's both anchor and both as a rebar models are ticked or satisfied, then you can go with an anchor design where you can potentially have a smaller embedment that satisfies the load criteria. So hope that answers that.
Thanks, Dimish. Then we have a new question. Is bond splitting basically failure between concrete and concrete rather than the bonding agent and concrete?
That is, I'll answer that. That is more or less correct. But it's basically accounting for the interface. So it checks for the interface itself. But it accounts for both the bond strength, but more so for the concrete factors and the splitting factors in between. So in that case, you are checking both the bond and the splitting of the concrete. So basically, it's both. It's the interface itself.
So it would be the interface between the cured bond or the cured chemical itself and the concrete, as well as the splitting failure of the concrete itself.
Of the concrete. Exactly, correct.
Thank you, Damish. That was the last question that we have in the questions chat here. If there are any other questions, feel free to type in here, please. I'll just give you guys a few minutes to make sure that there are no other questions.
Yep. So while the people are thinking of questions, I'd like to point out that we are in the process of developing new content for our live webinars for the rest of the year. So your feedback through the poll questions will be taken into consideration when developing this content. This QR code here, please use that as a means for getting the content that's more suitable for you and you would like to see. Also, I would say just reach out to your counterpart in Hilti if you know them. If you don't know them, just you can get in touch with us and we'll assign the right person to it. Okay, so I would say no further questions. So on behalf of Hilti Australia, myself and Randy and the rest of the team, including Hamdun and Mariana, would like to thank you for your attendance today, and we hope to see you next time. So goodbye.
Thank you. Goodbye.